afternoon we are continuing with our topic, which is reduction, oxidation, or redox reaction. Last class we discussed the definition of redox as reduction, oxidation in several ways. We use oxygen, we use hydrogen, we use electronegative elements, electropositive elements, oxidation number, and electron transfer. So we were able to discuss oxidizing agents and reducing agents. Can anybody remind us of what oxidizing agent is? What do we say oxidizing agent is? And what is reducing agent? Anyone from the class? What is oxidizing agent? Okay.
Oxidizing agents are substances that gain electrons.
Substances that gain electrons are referred to as oxidizing agents. Can you give an example of such substances? K2Cl2O7. That is right. Then what is reducing agent? Reducing agent. Okay. Let's have you.
Reducing agents are
Substances that lost electron are referred to as reducing agent. Can you give an example of such? Hydrogen sulfide. That is right. So we also discussed how we can test for these substances. For example, if we want to test for oxidizing agent, we say we use reducing agent. And if we want to test for reducing agent, we use oxidizing agent. Suppose we suspect the substance to be a reducing agent. What we do is to find the common oxidizing agents like acidified KMNO4. Acidified KMNO4 is purple in color. What you do is that you can put the reagent in the test tube. We have this like KMNO4, which is purple. If you add the substance you suspect to be reducing agent to it, if the color changes from purple to colorless, then you can say that what you have added is a reducing agent. You can say a reducing agent changes acidified potassium tetraoxo-7 from purple to colorless. And of course, we don't want to use KMNO4, we can as well use acidified K2Cl2O7. So instead of KMNO4, we can use K2Cl2O7. So now we can change this one now to K2Cl2O7. We have K2Cl2O7. What is color of K2Cl2O7? So it is orange. And if we want to add it, is reducing agent. What happens to it? It is to gray. And that is test. We can as well test for reducing agent. That means we use oxidizing agent to test for reducing agent. And we use a sample of iron 2 chloride. What is the color of iron 2 chloride? The color is green. So if a substance is added to iron 2 chloride solution, if the solution changes to reddish brown, it means what you have added is what? Reducing agent. I mean, it's an oxidizing agent because iron 2 chloride is a reducing agent. You want to test for oxidizing agent, you make use of what? Iron 2 chloride, which is what? A reducing agent. So the only substance that can change iron 2 to iron 3 is an oxidizing agent. So we can as well use potassium iodide solution to test for oxidizing agent. Potassium iodide is colorless. So what you do is that find this one Then you had, this is now the have potassium iodide aqueous, which is colorless. If the substance added to it changes this colorless solution to brown, then you can say what you have added is what? An oxidizing agent. I think that was where we stopped last class. So let's look at oxidation number. Now, oxidation number. The electrical charge possessed by a substance, the electrical charge possessed by a substance may be due to arbitrary rules are referred to as oxidation number. The electrical charge possessed by atom or group of atom as determined by a set of arbitrary rules are referred to as oxidation number. For example, there are some rules we must follow if we want to determine the oxidation number of elements in a given compound. Number one of those rules is this. We have one. A free element has oxidation number of 0. A free element has oxidation number of what? 0. That means when an element is standing on its own, its oxidation number is equal to 0. For example, if I write this is iron, this is chlorine, this is sulfur, this is nitrogen. Each of these elements has oxidation number of what? 0. Because each one of them is standing on its own. It's not combined with any element. So a free element has oxidation number of 0. 2. A charge on the ion is the oxidation number of the ion. That means when you write an ion will carry electrical charge. That electrical charge possessed by the element will be the oxidation number of it. For example, if you have iron 2 ion, sulfide ion, aluminum ion, oxygen ion. Each of these elements has oxidation number of +2, -2, +3, and -2 respectively. So the charge possessed by an ion is equal to the oxidation number of that ion. So just like we have on the board, iron has oxidation number of 2. It has a charge of +2. So its oxidation number is equal to +2. Then sulfur has carried negative charge. It means sulfide ion has oxidation number of -2. Ditto to aluminium, which has oxidation number of +3, and oxygen that has oxidation number of -2. Are we together? These rules I've given you will help us if we want to calculate the oxidation number of elements in a given compound. Sum of oxidation number of elements in a compound is equal to 0. If you are given a compound, when you add the atoms of elements that are present in that compound together, it will give us 0. The number of elements in the compound is equal to 0. For example, if you are given, let's look at this. This is compound. In this compound, how many elements are present? How many elements? So if you add the oxidation number of the elements together here, it should be equal to 0. But when you are given a radical ion, when you say a radical ion, a group of atoms that possess an electric charge is called radical ion. For example, let's continue here. For a radical ion, sum of oxidation number is equal to the charge on the ion. When you have a compound without charge, sum of oxidation number of elements together will give us 0. But when you have group of atoms that possess electrical charge, for example, if you have a MnO4 minus, this is an example of a radical ion. This ion has 2 atoms. What are what? What are what? Manganese ions. In this case, if you add the number of manganese to oxygen, what you are going to get is what? -1. That is different from one that has no charge. Is that clear? Now, frequently, how do you determine the oxidation number of some elements? It is very easy for you because not every element you know its oxidation number when it combines. But most times, elements in group 1 we have oxidation number of +1. Because those elements in group 1 have tendency to lose out 1 electron. And that electron loss will tell us the charge you carry. Elements like sodium, potassium, they are even lithium. They are in group 1. And each of these atoms will ionize by loss of electron. That means when they combine, they usually use their electron and their atmosphere to combine. In that case, when you see sodium, you see potassium, you see lithium in a compound, its oxidation number is going to be what? +1. Are we together? If you see group 1 element in a compound, I have given an example of sodium, potassium, and lithium. If they stand on their own without combining, the oxidation number is going to be what? 0. But when you see them in a compound, for example, I have Na2SO4. You can see we have sodium here in a compound. The oxidation number of sodium here is going to be what? +1. It is different from when you have sodium on its own. This is a free element, and we have said the oxidation number of a free element is 0. Are we together? So that means group 1 element, when you find them in a compound, its oxidation number is going to be what? +1. If you see group 2 elements, we have oxidation number of +2. You know, if you want to determine the oxidation number of an element, it is the valency electron that they will use for their combination. Group 1 element will use 1 electron. Automatically, their valency goes to be what? 1. And their oxidation number is going to be +1. Group 2 element has 2 electrons at the atom shell. What will happen to that 2 electron at the atom shell? They have tendency to lose that electron. And when that electron is lost, the ion becomes what? That element has oxidation number of what? +2. So when you see elements in group 2 in a compound, its oxidation number is going to be what? +2. So we are going to look at how we get this one. So we are going to look at some calculation here on how to determine the oxidation number of elements in a compound. Now, what are the importance of oxidation number? What are the importance of oxidation number? So let us look at the importance of oxidation number before you look at calculation. Importance of oxidation number. Importance of oxidation number. Now, one, if you want to name inorganic compound, you need a number of the elements there. So it is used for naming inorganic compound. Number one, it is used for naming inorganic compound. For naming inorganic compounds. I'll give an example. I have this. Can anybody tell me the name of this compound? Yes? Tetraoxosulfate 6 acid. You measure what? 6. Where is the 6 from this compound? As you can see, look at the compound here. You only have 2 and 4. Where is that 6 from? It's as a result of the oxidation number of sulfur. So it means if the knowledge of oxidation number is not understood, you will name inorganic compound wrongly. So one of the importance of it is that it is used for naming inorganic compound. Are we together? Now number 2. Oxidation number is used to determine the oxidizing agent and reducing agent in a compound. To determine the oxidizing agent and reducing agent in a given ionic equation. Let's put that in. To determine the oxidizing agent and reducing agent in an ionic equation. So you are going to look at, I will see this importance there. By the time we begin to look at balancing of ionic equation, I will explain that one in detail. How we use oxidation number to identify oxidizing agent and reducing agent. Number 3. For balancing, it is used for balancing ionic equation. So oxidation number is also used for balancing ionic equation. Oxidation number is used for balancing ionic equation. So these 3 are the importance or the common importance of oxidation number. Now let's look at how we can calculate oxidation number of elements in a given compound. So let's look at these questions together. So let's look at this. Calculate the oxidation number of the underlying elements in the compounds or radical ions below. and state their IUPAC names. Then we have 1 H2SO4. I know everyone of you, just as I have asked you before, the name of this compound, you say it's tetraoxosulfate acid. Then how do you get that 6 from this compound? Now we have 1. Let's look at 1. We have H2SO4. This is what you are looking for. That means it is essential that you must know the oxidation number of this first element and the last element. And I've told you how to know that. Hydrogen belongs to which group? That means it will be a oxidation number of what? 1. That is +1. But there are 2 atoms of hydrogen here. That's going to be 1 times 2. Remember the rule is that sum of oxidation number of elements in the compound is equal to. So now plus, we just know oxidation number of sulfur. Let's use S to represent that oxidation number. Plus, what is oxidation number of oxygen? That is what? Minus. How do you arrive at that? You know, it's the valence electron that we have at the atom, that electron at the atom that will tell you maybe an element will lose electron or gain electron. What's the atomic number of oxygen? 8. It means oxygen will have 6 electrons at the atom shell. For oxygen to become stable, what will it do? It will attract or gain 2 electrons. So when that electron is gained, it will have what charge? You know, when an element loses electron, it carries positive charge. But when it gains electron, it carries negative. And that charge depends on the number of electrons gained or lost. How many electrons will oxygen gain? So that is why we have the oxygen number of oxygen to be what? -2. How many atoms of oxygen do we have? That is -2. And 4. Everything will give us what? Then we have this one to become 2 plus x. What is -2 times 4? That is -8 equals what? 0. Then this gives us x minus 6 is equal to what? 0. Then x is equal to what? It is important for you to put the plus there. This is not mathematics that you say positive means nothing. Positive here means a lot of things. Because if you define oxidation number, how do you define it? How do you define oxidation number? The electrical charge. What makes it to be oxidation number is what? The charge you have here. Please, when you are asked to calculate the oxidation number of an element, do not omit the charge. It is important. Now, then the name of the compound now becomes what? You can say hydrogen tetraoxosulfate 6, or you can say tetraoxosulfate acid. That means that acid has taken care of the hydrogen. So the name of the compound is what? Hydrogen tetraoxosulfate 6. You not say sulfate acid again, no? Are we together? Yes, not hydrogen tetraoxosulfate acid. If you must omit the hydrogen here, you put acid. And once the acid is there, then you don't need to put the hydrogen. Are we together? Yes. That is important. So that means if you are to name a compound, if you are talking of inorganic compound, we have organic compound. That is why I say it's used to name what? Inorganic compound. If you want to name organic compound, you don't need oxidation number. Or have you named any organic compound that has charge with it? Maybe 81 chloride plus, let's use Al to represent the oxidation number of aluminium plus. Now, you know this is hydrogen. What will be the oxidation number of hydrogen here? Why is it minus 1? We use this one to the 1. Why does it become minus 1 here? Yes? Why? Now we've just done 1 here. We say this is hydrogen and we use positive 1 here. But on getting here, you say it is minus 1. Why is it minus 1 here? It's anhydride. I want detailed explanation. Hydrogen can act as a metal most times and non-metal. That means it can lose electron, it can accept electron. Here, when you are having hydrogen in an anhydride, that means it's collecting electron from aluminum. So it acts as an anhydride, and in that case, its oxidation number is going to be what? Minus 1. So we have this one to be minus 1 times 4 is equal to 0. So we have 1 plus An minus 4 equals 0. Then what is 1 minus 4? N is equal to 0. Then An will be equal to what? Remember, the charge is very important. So the oxidation number of aluminum in that compound is equal to plus 3. Then what will be the name of the compound? We have, it will be what? Lithium tetra hydrogen aluminate. Aluminate what? 3. You can see the importance of the oxidation number. If we don't know the oxidation number of aluminium, it will be difficult for us to name the compound. Can you please do the remaining 3 and tell me what the name is? Try the remaining 3. CSO4, KNO3, and K3F2 brackets, CN86. Do the remaining 3 and let's see what the name of the compound is. Two elements we have oxidation number of 2. So we have 2 plus S plus, this is oxygen. Its oxidation number is equal to minus 2. So we have minus 2 times 4, and everything will give us 0. So this is 2 plus X minus 8 equals 0. Now what is 2 minus 8? So that is X minus 6 equals 0. Then X is equal to 0. So the name is calcium tetra oxo sulfate what? 6. So let's look at circle the third one. This is, so what is the name of this? Potassium diazoxide. It shows that the number of nitrogen there is what? +3. So let us look at it, how we arrive at that. We have K NO2. Potassium, we have oxidation number of what? +1. So that is plus that of nitrogen plus, we've said oxidation number of oxygen is equal to -2 times 2 because there are 2 atoms, and everything will give us 0. Now 1 plus nitrogen now -4 equals what? 0. Now what is 1 minus 4? 2 minus 3 equals 0. Then N is equal to 3. Hence the name is potassium what? Dioxo nitrate. That is 3. Dioxo nitrate 3. Then the last one here, which is K3F3 bracket Cl6. What will be the name of this? Potassium hexacyanoferrate 3. It means the oxidation number of ion here is what? So let us look at. Now we have K3FeCl6. Of course, we know this is potassium is in group 1, so its oxidation number is going to be +1. So that is 1 times 3 because there are 3 atoms of potassium there. Plus, let's use Fe to represent the oxidation number of. This is carbon and nitrogen, which we call cyanide. What is the oxidation number of cyanide? Most time, if you want to determine the oxidation number of group of atom like that, what we do is to find the difference between their valence electron. What is the valence electron of carbon? 4. What is valence electron of nitrogen? It is what? Do you understand what's meant by valence? I'm talking of the electron you have at the outermost here. What's the atomic number of nitrogen? 7. So you have how many electrons in the first shell? Then how many do you have at the outermost shell? 5. And that is what we did for carbon. Atomic number of carbon is what? 2 electrons in the first shell, 4 electrons at the outermost shell. So automatically you are going to have 5 electrons at the outermost shell. By the time you find difference between 4 and 5, what do you have? That is why we consider that to go -1 times 6 because there are 6 atoms. And everything together will give us what? So this is 3 plus Fe minus 6 equals what? 0. Then we have 3 minus 6 will give us -3, and that is equal to 0. Then Fe will give us what? Plus 3. It means the oxidation number of ion in that compound is what? And the name becomes what? Potassium hexa means 6. Hexacyanoferrate. You know, the ion here got its name from verum, which is Latin name. And that is why we are having what was ferrate, not ionate. Is that taken? So ferrate what? Ferrate 3. Are we together? So that is one of the importance of oxidation number. It helps to name inorganic compound. Is there anybody here that cannot calculate oxidation number of elements in a given compound or ion? Please talk so that we do more examples. So you can all do the calculations. I'm not talking. You can do it. I don't buy any.
Yes, sir.
I don't buy. Some of you will not listen to the question before you answer. Because you believe every answer to a question is yes. Even when you are asked, are you stupid, you say yes, sir. Now, let's move on to balancing ionic equation. How do we balance ionic equation? How do we balance ionic equation? So if ionic equation is given to you, there are steps you follow if you are to balance the equation correctly. So we are going to look at those steps that are required, and I will give you some equation to balance them, either in acidic medium or alkaline medium. Now, number one step is to identify. You identify the oxidizing agent and reducing agent. So identify the oxidizing agent and reducing agent that is present in the equation. Whenever ionic equation is given, it will come with oxidizing agent and reducing agent. You should be able to identify the oxidizing agent and reducing agent. In fact, once you know these steps, even when you are given a balanced ionic equation and the equation say identify which of the species is reducing agent and which one is an oxidizing agent, you should. Then how do we identify oxidizing agent or reducing agent? Of course, we said oxidizing agent gains electron, reducing agent loses electron. You cannot see how the electron will be lost, because the equation will not tell you that electron is given to this or electron is accepted by this. But what will tell you that electron is gained or lost is the charge. When there is increase in charge, it shows that the element has lost electron. That substance that is losing electron will be what? A reducing agent. And when there is decrease in oxidation number, it shows that that element has gained electron. You will not see how electron is lost or gained. But how will you know that electron is lost or gained? If there is increase in charge, the element loses electron. So is what? A reducing agent. If there is decrease in charge, it shows that the element or the substance gains electron. Then that substance will be what? Oxidizing agent. I hope you understand. Even if you don't understand, by the time we look at one equation, you understand how to identify the oxidizing. Just know how you are going to identify the reducing agent and oxidizing agent is by looking for what the charge that is present in the atom. If there is increase in charge, it shows that the element loses electron, then that substance will be a reducing agent. But if there is decrease in charge, it shows that the element gains electron. Then we can say the substance is what? The substance is what? That's it. So identify the oxidizing agent and reducing agent. Once that is done, you break the equation into two halves. You are given one equation, you break it into what? Two halves. Oxidation half equation and reduction half equation. So what we do number 3 is that write oxidation half equation from reducing agent. And the reduction and reduction have equation from where? From oxidizing agents. What we are saying here is this: oxidizing agents will undergo reduction. Oxidizing agent will do what? Will undergo reduction, while reducing agents will undergo oxidation. And that is what I'm raising here. Write oxidation half equation from here? Reducing agent, and a reduction half equation from oxidizing agent. The essence of giving you these terms is that you may be given a balanced equation, then you have to split it into two. Write or split the equation into two halves. That means you write oxidation half equation and what? Reduction half equation. How will you know the one that will undergo oxidation or the one that will undergo reduction? Once you have identified oxidizing agent, you know oxidizing agent will undergo what? Reduction, while reducing agent will undergo oxidation. It's low. Don't worry. Example will be given. All this story will not be like that. It looks boring or it looks confusing. If you go by definition, that's what when I was explaining last week, I told you have to be very careful when you want to give definition of oxidation reduction. Otherwise, you will get zero. It's somehow later. When you say a process is for oxidation, but the substance that is performing is the agent. When you say a substance that loses electron is called what? Reducing agent. The process of losing that electron is what? Oxidation. The substance that is losing electron is what? Reducing agent. But the process of losing that electron is what? Oxidation. That is why we say reducing agent will undergo what? Oxidation. A substance that gains electron is the oxidizing what? Agent. What is gain of electron? What's the process of gaining electron? Reduction. And that's why I say oxidizing agent will undergo what? So number 3. We have broken the equation into two halves. All we need to do now is to balance each half. Are we together? We balance what? Each half. So, balance the oxygen atom or atoms with hydrogen ion and water molecule when balancing a acidic medium or hydrogen ion and water molecule when balancing in alkaline medium. Balance the oxygen atom with what? With what? We use hydrogen ion and water molecule. If we are asked to balance the equation in acidic medium, it will be specified. If you have to balance the equation in acidic medium or alkaline medium. When there is disparity in oxygen atom, we are making use of hydrogen ion and water molecule. If we are asked to balance in acidic medium. But if you are asked to balance in alkaline medium, what do we use? Hydroxyl ion and water molecule. Are we together? Now, the next step now. The next step is to balance the charge. Balance the charge. There's a balance balance the charge with appropriate number of electron or electrons. Balance the charge with what? Appropriate number of electrons or electrons. The first point is balance the charge with appropriate number of electrons or electrons. Where they are different in charge, you balance it. Usually, when you want to balance charge, the electron you are using should be added to where there is increase in charge. We'll look at that later. Now, ensure, number 5, ensure that electron loss and oxidation have equation is equal to electron gain at the reduction equation. You know, electron loss must be equal to electron gain. If you have 3 electron loss and oxidation, then you have 5 loss. I mean, electron loss, 5 electron loss and oxidation, you have 3 gain at the reduction. Will it be like that? So what you do is that you multiply so as to make the number of electron loss equal to the number of electron gain. The final one now is combine the two half equation. Combine the two half equation to obtain what? To obtain the balanced ionic equation. It may look long, but it is very simple to balance. I have given you all these steps so that whatever thing you have to do on ionic equation, you'll be able to do it perfectly. Either you have to balance the equation, or you are given balanced equation, you have to split it into 2. Or you have to identify the oxidized species or reduced species. Now let us look at one. Examples. Examples 1. Balance the equation below in acidic medium. So we have this equation to be balanced in acidic medium. Yes, the first step, let us follow the step we have here. Identify the oxidizing agents and reducing agents. Which of these substances is an oxidizing agent and which one is a reducing agent? Which one is a reducing agent? Fe. Why is Fe a reducing agent? reactions that are contained. We said Fa is the reducing agent, and I told you the reason or how to identify the reducing agent. Oxidation number of ion here is 0. Here it is what? When there is increase in oxidation number of an element, that element will have lost electron, and it means it is a reducing agent. Now, if you look at manganese here, what is oxidation number of manganese here? +7. Here it is what? What happens to the oxidation number? It decreases. That means this is going to be what? Oxidizing agent, and this is reducing agent. Now I believe you know how to identify reducing agent and oxidizing agent. A reducing agent can be referred to as oxidized species. A reducing agent can be regarded as what? Because if you are given a balanced ionic equation, you may be asked to identify oxidized species or reduced species. So a reducing agent is also known as what? While oxidizing agent is referred to as a reduced species. Is that okay? Now, what's the next step here? We'll split the equation into two halves. From reducing agent, we write oxidation half equation. So we have Fe going to Fe2 plus. Then this is oxidation half equation. Then from oxidizing agent, we write what equation are we writing from oxidizing agent? Reduction half equation. It means you have MnO4 minus going to Mn2 plus. This is reduction half equation. Reduction half equation. I hope you are following. What's the next step? Balance what? Oxygen atom. The question, we are balancing this equation in acidic medium. It means we are making use of hydrogen ion and water molecule. Do we have oxygen atom in oxidation half equation? That is not applicable to the first equation. But here, we have oxygen here. So we'll balance the oxygen atom with hydrogen ion and water molecule. It is very simple. And there is no magic on it. We don't have oxygen here. It means where we don't have oxygen or we don't have enough oxygen, what we do is to add water molecule. Because from water molecule we get oxygen. How many oxygen atoms do we need? That means we are going to add 4 water molecules. You come here, you add 4 water molecules. Automatically we have balanced the oxygen atom. Then from the 4 oxygen atoms that we have added, you can see we have gotten what? How many hydrogen have we gotten here? 8. That means you go to this side, you add what? 8 hydrogen ion. Automatically we have balanced the atoms. From here, we can see the atoms are balanced. Manganese, oxygen which is 4, oxygen which is 4, hydrogen which is 8, and hydrogen that is also what? 8. If we are to be alkaline medium, instead of hydrogen ion and water molecule, we are going to use what? Hydroxyl ion and water molecule. What's the next thing? Balance the charge. How are we balancing the charge? How? Or what are we using to balance the charge? What? Electron. If you look at this, it's applicable to this one. Is the charge equal here? What charge do we have here? What else do we have here? What is different in that charge? 2. That means you are going to add 2 electrons. The electron should be added to where there is increase in charge. Where do you have increase in charge here? At the right hand side. So we have what? Plus 2 electrons. So that is, and we are done with that. Then you come to the second equation, which is reduction equation. What is total charge we have here? What total charge we have at the left hand side? Plus 7. Do you all agree with that?
Yes, sir.
The charge of MnO4 is minus 1. We have 8 hydrogen ion here. That would be 8 charge. Minus 1 plus 8 will give us what? 7. What total charge we have here? That is plus 2. What is the difference between the charges now? 5. That we are going to add 5 electrons. Where will that electron be added? At the left hand side. So we have plus 5 E minus. I think we have explored what we have here. What is the next one? Ensure that electron loss at the oxidation half equation is equal to electron gain at the reduction half equation. What do we do? If electron loss should be equal to electron gain, what do we do? We multiply the equation 1 here by 5. I multiply this equation by what? By 2. That means oscillation half equation should be multiplied by 5, while reduction half equation should be multiplied by 2. The essence is this. We want to eliminate the electron because oxidizing agent is gaining electron that is lost by reducing agent. So it must be equal. So by the time we multiply 5 here by 2 electrons, we get what? And by the time the 2 here is multiplied by 5 electrons, we get what? 10. But the whole equation must be multiplied. So that means we have 5 Fe giving us 5 Fe2 plus 10 E minus. Then we have 2 MnO4 minus plus 16 hydrogen ion plus 10 electrons will give us what? 2 Mn2 plus 8. Now electron loss cancel electron gain. So electron gain has cancelled electron loss, and that is essence of ensuring that electron loss at the oscillation half equation is equal to the electron gain at the reduction half equation. Then what do we do now? What we have broken should be combined together. So write the equation at the left hand side together and the one at the right hand side together. So the equation now becomes 5 Fe plus 2 NnO4 minus plus 16 H plus to give us 5 Fe2 plus 2 Mn2 plus what? Plus H2. You can then check your answer, your equation, if it is balanced or not. You check your equation if it is balanced or not. Now let us check if you have balanced the equation correctly. The equation is correct, but let's look at if it is balanced now. So we have 5 Fe. We have what? 5 Fe. There are 2 manganese here. There are 2 manganese here. How many oxygen atoms? 8. How many oxygen atoms? How many hydrogen do you have? How many hydrogen do you have? That means the atoms are balanced. But this equation is not balanced, except to check for charge. And that's what I said, oxidation number is used for balancing the ionic equation. If the charges are not correct, you have not balanced the ionic equation. The charge at the left hand side must also equal to the charge at the right hand side. So let us look at the charge. This is 2 minus 1. And you have minus 1 here times 2. That is minus 2. We have minus 2 here. 16 times plus 1, this is plus 10. And that will give us what? Plus 14. 5 times plus 2, plus 10. 2 times plus 2, plus 4. And that is what? Plus 14. That means the equation is balanced. So if you do your own balances, if the atoms are balanced and the charge is not balanced, your equation is not yet balanced. It means you must have done something wrong, so you have to check. So, can we do one more example? Can we do more example? Or you understand I should give you the ones you try? So let's have one more example. We have Fe2 plus Cr272 minus will give Fe3 plus Cr2 plus. So we want to balance the equation in acidic medium. Since you are balancing acidic medium, I decided not to follow the steps here. I've described the steps for you in order for you to know how to answer any question given to you on redox reaction. Are we together? The purpose of giving you these steps here is to be able to solve any equation, any question given to you in ionic equation. I decided not to follow the steps here and I balance the equation here. I know Fe2 cannot lose electron or gain electron to give Cr3 plus. Will it? Can Fe2 give me Cr3 plus? So I know I'll break the equation into 2. Fe2 plus will give me Fe3 plus. Is that? Then I know Cr2072 minus will give me Cr3 plus. I've broken the equation into 2 halves. The only thing is that how do I identify which one is oxidation half equation? How do I identify the one that is reduction half equation? Which one will undergo oxidation half equation? Which one will undergo reduction half equation? Which one is oxidation half equation? Which one is reduction? The first one is oxidation because you know there's increase in oxidation. That means it loses electron. So this is oxidation half equation. So why are you going to be what reduction half equation? The atom in the first one is balanced. The atom is balanced. But in the second equation, is the atom balanced? Number 1, you have 2 chromium here, we have 1. First of all, balance the chromium. Is it balanced again? It remains what? Oxygen. What do we use to balance oxygen? Remember, we are balancing in acidic medium. Then we are going to use hydrogen ion and water molecules. Where we don't have the oxygen or there is shortage of oxygen, water molecule will be added. How many oxygen atoms do we need? How many oxygen atoms? 7. So we add what? 7 water molecules. From 7 water molecules, how many hydrogen do we have there? That means we come here, we add what? 14 hydrogen ion. Now the atoms are balanced. What remains is what? The charge. What side do we have here? +2. What side do we have here? What's the difference? 1 electron. That we are going to have what? 1 electron. How many electrons? We have the electron. Right or left? That's the right hand side. So we have plus E minus. So the charge is balanced. Then how do we balance the charge here? What is total charge we have? Okay, there is minus there. What total charge we have here? 12. This is -2. This is +14. That is what? 12. What total charge we have here?
6.
What is the difference in charge? How many electrons are we adding? Then where are we adding the 6 electrons? So we have +6 minus. The next step is for us to ensure electron loss equals electron gain. What do we do to do that? Multiply equation 1 by 6 and this by 1. So this gives us 6 Fe2 plus to give 6 Fe3 plus 6E minus. And this means Cr2O7 minus plus 14 hydrogen ion plus 8 minus to give sugar plus 7 H2O. The electron gain cancels electron loss. What do we do now? -12. So we have 6 Fe2 plus Cr2O72 minus plus 14 hydrogen ion to give us what? 6 Fe3 plus 2Cr3 plus 7 H2O. Then you can always check the equation if it is balanced or not. Can you do that for me? Let's see the equation. Okay, let us do this because I'll give the other one. So we have iron here is 6. How many iron do we have? I'm not talking. Are you tired? If you are tired, you can carry your bag and go. You are hungry. So how many chromium do we have? How many chromium do you have here? How many do you have here? How many oxygen? How many oxygen? How many hydrogen? How many here? Yeah, look at the charge. 6 times 2 minus then plus 14. That is what? 24. That is plus 24. 6 times 3 plus 6 plus 24. So the equation is balanced. So the atoms and the charge was a balance for you to know that the equation is actually balanced. Is it difficult? Very sure if you are given any equation like this, straightforward, the balanced equation. Within 1 second, the equation should be balanced. Yes, balance this one in acidic medium. If time permits us, we will balance it in alkaline medium. If there is no time today, when we meet tomorrow, we'll look at the equation that you have balanced in acidic medium. We are going to balance them in alkaline medium. The given equation can be balanced in both acidic and alkaline medium. The only difference is just the OH and IH. Now balance. To balance that equation in acidic medium. NO4 minus plus C2O4 2 minus to give Mn2 plus CO2. Balance the equation in acidic medium. This equation will not take you more than 2 minutes. Equation into 12. MnO4 minus will give us what? Mn2 plus. Then C2O4 2 minus will move to CO2. Which reaction is the first one? Reduction. Because you can see that decrease plus 7 2 plus 2. So this is reduction, half equation. Automatically this is what? Oxidation, half equation. Now balance the atom. How many water molecules are we having at the right hand side? 4 water molecules here. Then how many hydrogen are we having here? 8. That is 8 hydrogen ions. Carbon is 2 here. You put 2 here so that the carbon atom will be 2. Before we talk of oxygen atom at all. How many oxygen atoms do you have? How many do you have here? Are we adding water molecule and hydrogen ions? Because there is no difference in the oxygen atoms. It's only when you add difference in the oxygen atom you are going to add hydrogen ion and water molecules. Then what do we do now? We balance the charge. Let us balance the charge. How many electrons are we adding at the reduction application? So we had 5 electrons. How many electrons are we adding at the oxidation application? 1, 2, 2. You see, there is no charge here. This is 0. We only have 2 electrons, 2 minus 2 here. That means we are adding 2 electrons. Where are we adding electrons? Right hand side. We have plus 2e minus. How do we balance the electron loss and gain? Multiply the first equation by 2 and the second one by 5. That you are going to have 2MnO4 minus plus 16H plus 10E minus to give 2Mn2 plus 8H2. And this one gives us what? 5C2O42 minus to give us 10CO2 plus 10E minus. Electron loss cancel, electron gain. They combine the two halves. That is 2MnO4 minus plus 5C2O42 minus plus 16H plus. This gives us 2Mn2 plus 10CO2 plus 8H2. So if you check the equation, find out that the equation is balanced. Where do you miss it? You make sure you balance the atom before you balance the charge. Before we call it again, balance this equation. So split this equation into two halves. Split the equation. Split the equation. That is, break the equation into two halves. Split the equation into two halves. What you are writing is nonsense. Going to EP. This half equation is not balanced. You must put the charge. Majority of did not put charge there. You just write like this and leave it. Is this equation balanced? When the charge here is plus 2, the charge here is 0. So you must always balance the charge with electron. So that will be what? Plus what? 2 electrons. Then you have Al goes into what? Al3 plus. Then what do you do? Plus what? 3 electrons. And that is what I asked you to do. If you are to balance this equation, suppose you have to balance the equation here. Then you move a step forward to ensure that electron gain is equal to electron loss. Multiply by 3 They multiply by 2. You cannot combine them. You are going to have a balanced ionic equation. That's okay. Yes. Now let's look at this one. Or since 4 o'clock, I will say 5 o'clock. Balance the equation below, or balance the following equations. Balance the following equations in acidic medium. 1. So, these are the assignments for you. Solve the equation. Ensure you balance them correctly. Then when we meet tomorrow, I'll do the corrections here. So thank you for listening.